Alright, let's move on to the next question. He says, a 3 into 3 square frame is placed on a grid of numbers. You can see grid of numbers and 3 into 3 square frame. So basically, if you can see, this is the 3 into 3 square frame is placed. In the example, the sum of numbers inside the frame, right? So as you can see, I have 4, 5, 6, 11, 12, 13, 18, 19, 20. And the sum of these numbers is given to be 108. And the middle term, as you can see, that is 12. Right? Now he says when the frame is moved to a new position, the sum becomes 288. Right? So if I shift this somewhere else, the sum of the numbers is given to be 288. In this position, what is the middle number? Right? Now, if you can observe, the sum of the numbers is 108 and the middle term is 12. So you can see that 12 and 108 are directly related to one another. Right? This is nothing but 12 into 9. Now, is that a coincidence? Let's check it out. Now, the middle term is 12, right? Okay, so 12 is there. So 12 plus. Now, this number is nothing but 12 plus 1. Right? 13. And this is obviously 12 minus 1. Right? Okay. And if I go back to this number, this is nothing but 12 minus 7. So let me write it here. 12 minus 7. And if I'm talking about this number, that is 19, 12 plus 7. 12 plus 7. Right? So I'm done with these. So let me go back here. So this is 12 minus 8. This is 12 plus 8. So 12 minus 8 and 12 plus 8. Right? So these two numbers are also done. And this is 12 minus 6, 12 plus 6. So these two numbers are also done. So I should have actually written it here, 12 minus 6 and here 12 plus 6. This sum is given to be 108, which was very obvious. Why? Because minus 8, 8, minus 7, 7, minus 6, 6, minus 1, 1, and obviously 12 is there. So you can see 9 into 12, which is 108. Right? So if the sum of the numbers is 208, the middle number what should be? What should it be? It should be 288 divided by 9, which is nothing but 32, which is the answer. On to the next question. Now he says if f of x be a polynomial of lowest degree with rational coefficients, lowest degree and rational coefficients, of which one root is given to be there. The better word should have been 0, but it's fine. You get the gist of it, right? So lowest degree polynomial with rational coefficients and 1 0 is given to be that. Suppose the coefficient of the linear term is minus 18, then write the numerical value of the constant term of f of x. If I'm able to write the polynomial f of x, I can write the constant term and the numerical value, right? Now, let's just study. One root is this, and I want a polynomial with rational coefficients, right? So if I'm considering my polynomial in x, I know one value of x is nothing but cube root of 3 plus 2 into cube root of 9. Right? Using this, I need to make a polynomial with rational coefficients. That means radical sign should not be there. Now, radical sign, I want to remove it. And obviously, let me see. I cannot leave it like this. Radical signs are there. If I square it up, radical sign will not disappear because I want to get rid of cube root. If I want to get rid of cube root, that means I need to cube it. So, I can do that. X cube is equal to cube root of 3 plus 2 into cube root of 9 whole cube. Right? Because clearly if x is equal to this, x also satisfies this equation. Right? So a plus b whole cube I can write it. So that is a cube which is 3 plus b cube which is 2 into cube root of 9 whole cube. So 2 cube that is 8. 8 into 9 that is 72 plus 3ab. So ab. So multiply that. So cube root of 3 into 2 into cube root of 9 into a plus b, right? 3ab into a plus b. Now a plus b, you have substituted as x, right? This is equal to x cube. If you simplify it, you will get x cube minus 18x plus 7 minus 75, that is equal to 0, right? The polynomial f of x is this one, x cube minus 18 minus 75, right? Lowest degree polynomial, rational coefficients, and obviously one of the root is this. Right? Now he says write the numerical value of the constant term. Constant term is what? Minus 75. I just want the numerical value, as in the number associated with it, which is 75, which is the answer. Alright, on to the next one. Now he says ABCD is a trapezium. So let me have my screen. But before that, AD being at right angle to AB and AD is actually perpendicular to AB as well as DC. So I will make the trapezium accordingly. So suppose my trapezium looks like this. Alright, so this is A, B, C, D. Right, now he says that AD is 10, so this length is 10. DC is 8, so this length is 8. Now he says, and diagonals BD and AC cut at 90 degrees. Alright, so diagonals cut at 90 degrees. Right, so this angle is 90. Now, and again I'll mark this 90, this 90. Since it's a geometry question, I would advise please write all of these things in your diagram. Right, now he says write the value of 2 by 5 into area of ABCD, which is trapezium. That means indirectly I need to find the area of trapezium. Now I know that area of trapezium is nothing but half into height into sum of parallel sides. Right? Now let's see, what do I know? Do I know height of the trapezium? Answer is yes, because I already know this length, which will be the height of the trapezium, which is 10 into sum of parallel sides. Obviously this and this are parallel, right? 90, 90. Now that means I want this plus this. This plus this one, so already I know this one, which is 8. Plus, now the other parallel side is 8. That means I can find the area of trapezium provided I know this length 8. Right? I'm interested in this now. I'm interested in the length of a triangle. Now the thing is, how do I get this length? Mind it, I have to make use of the fact that it is a trapezium, that this is 90, this is 90. Also till now, I have not touched the fact that this is 90 degrees. Diagonals intersect at 90 degrees. Now, in how many different ways can I use 90 degrees? First thing that comes to my mind, that is Pythagoras theorem, right? This is also 90 degrees. I'm interested in this. But for that, I need to know this length, right? Let us be O. I need to know AO. I need to know BO, right? It will be difficult to get these lengths as such because all I know is that 10 and 8, right? Okay. So maybe Pythagoras theorem is not being applied over here. So what else can I use 90 degree for? Now, side of the triangle, maybe I can find some congruent triangles. But the thing is, I don't think I can find congruent triangles over here. Right? What kind of triangles can I actually find? If congruent triangles are not there, maybe similar triangles are there. Right? We know the ratios are fine. Now, let me find these similar triangles. Mind it, since I need to find AB, I should look for the triangles where AB is the side. Right? So I can have ABD. ABD. Right? Let me consider this triangle. Right? First of all, AB is involved. Secondly, 90 degrees involved. Right? So many 90 degree right angle triangles are there. Right? So obviously I will choose a right angle triangle because I need to go for similar triangles. So let me consider triangle ABD. I'm not writing the corresponding parts. I'm just considering it. And the second triangle that I can consider. Now I know AD. I know DC. Right? Both of these lengths I need to accommodate. So that means maybe I can use this triangle ABC. Right? So I've considered this one and I've considered this one. Let me say whether these two triangles are similar or not. Obviously this is 90, this is 90. One angle is fine. Now the second angle I need to correspond. Now how do I go to the second angle? Alright, let me start from somewhere. So in this triangle, let me start with this angle. Let this be theta. Right? Mind that this is theta, this is 90, this is 90 minus theta. The entire is 90, this is 90 minus theta, that means this is theta. That means theta is present in this triangle and theta is present in this triangle. So that means this triangle is actually similar to this one. Right? Two angles are equal. So let me write the corresponding parts now. So triangle ABD is similar to triangle. Now corresponding to A, I will have B. Corresponding to B, I will have A. So DAC. Done? Let me write the corresponding parts. Obviously, I need AB, so let me write AB by DA. DA is nothing but is equal. Now, I will write that side which I know, BD. Now, BD I do not know, so I will not touch it. AD, let me check. AD. AD, again I know that is 10. Divided by DC, which again I know that is. And AB is nothing but 25 by 2. Right, just substitute it and you will be getting answer. The answer for this question is 41. Alright, the next one, which is quite interesting because if you know how to read the clock, you already have the answer. Alright, now it says how many positions are there on a regular clock? So obviously from 12 to 12. With minute hand and second hand in a coincident position in 1 hour. Right? Okay, so minute hand, the longer one, and the second hand, even the longer one. Coincident position. So that means their positions should coincide. Alright. Now he says in 1 hour. So I'll just take any particular 1 hour. So I will understand from 12 noon to 12:59. Right? Because 1 o'clock, exactly 1 o'clock, we'll move on to the next one. Right? So in fact, 12 noon to 1, I should say. Right? So that will get confused. Now let's start. Now at 12 noon, obviously I know that the minute hand is here and the second hand is here. Both are coincident. Alright. Now what is happening when I'm going to 12:01? In 12:01, obviously the second hand will go forward, right? Because in 1 minute, the second hand needs to complete the entire rotation. Is that fine? Right? So when I'm moving to 12:01, the second hand will move. In fact, I'll show it like this, moving. Here it comes back. Now when 12:01 is there, the second hand is here, but the minute hand is there. Right? So first obviously they have coincided at 12:01. Now, when will they coincide? Let's see. Now, the minute hand is at 12:01. Now, obviously, it will move forward a little bit, right? And obviously, the second hand is faster, so it will try to overtake, and it will overtake, but there will be a position between 12:01 and 12:02 when their positions will be same. So, there will be a time between 12:01 to 12:02. I am not interested at what exact time. Because he says how many positions are there. So I know between this time and this time, they are coincident once. So that is more than sufficient for me. Is that fine? Right. Moving on. Now suppose it is 12:02 now. At 12:02, the minute hand is here and the second hand is here. Right? Again, the second hand needs to complete the entire rotation. Right? In that period, the 12:02, this hand will move from 12:02 to 12:03. So just slightly. Cool. Again, when it is moving slightly, the second hand will come from behind, coming, and then there will be a position between 12:02 to 12:03. Then these two hands will be coincident. Right? Okay. Now I can do the trauma again. I can show that 12:03 and 12:04 there would be another position. Right? But I can see the pattern. So it is going on. I come to 12:56 to 12:57. Again, coincidence. Then we have 12:57 to 12:58, and then we have 12:58 to 12:59. Let me go to the extreme position in order to ascertain the answer. Now what happens at 12:59? Let's see, 12:59, my minute hand is here, right? And my second hand is here. Now, in 1 minute, this hand will go from here to here, the minute hand, just slightly, and the second hand will have to go through an entire rotation. Cool? So, it is moving forward, obviously, in that direction, and this moving in this direction. And it is faster, but the problem is, when it is moving, these two will coincide again when the minute hand moves to 12, and the second hand also moves to 12. Right? So between 12:59 to 12, or 1 o'clock we should say, there is no coincidence. Right? Because between this and this, actually they will coincide exactly at this point, but that will be for my next start, that is 1 o'clock. So it will not be counted from 12 to 1. Right? Because when we say 12 noon to 1, I do not include this time. Right? So how many positions? Obviously we are starting from 00 and we are going to 58. That is why the answer is 59. Or you start the clock, observe it, and you'll have the answer. Alright. For the next question, he says consider this equation where R is real. Now he says this equation has two distinct solutions. Now, a quadratic equation has two distinct solutions, which are both negative, right? So, two distinct solutions I have, and both of them are negative. So, negative, negative. Exactly when P is less than R, less than Q. So, that means there is a restriction on R basically. Right? For some real numbers P and Q, you need to write the value of Q minus P. Right? So basically Q minus P, you need the restriction on R. Right? So you need to find where R is very strong. From which value to which value. Now two conditions are given to you. First is, it has distinct solutions. Right? A quadratic equation has distinct solutions. That means discriminant needs to be greater than 0. Right? Okay. So, discriminant greater than 0. So, let me write my discriminant, c square minus 4ac. So, r plus 7 whole square minus 4 into a is obviously 1 into c, which is obviously r plus ab. He says this is greater than 0. Right? This will actually turn out to be quadratic, which you can factorize. It turns out to be r plus 23 into r minus 30 greater than 0. Right? That means r is either greater than 30 or r is less than minus 20. Either this is the case or this is the case. First condition done. Now, let me utilize the second condition. Second condition is both the roots are negative. Both the roots are negative. That means, what can I say about coefficients? Because r is involved in the coefficients. What can I say about the coefficients of the equation? Mind it, if both the roots are negative, that means sum will be negative. Right? Now, sum of roots you can have using the coefficients. Also, if both the roots are negative, that means product has to be positive. Right? Now, first of all, sum is negative. Sum is nothing but r plus 7. R plus 7 is negative, that means less than 0. Right? And at the same time, he says product is positive. Product is nothing but r plus 87. Positive greater than 0. Right? From here, I can say r is less than minus 7 and r is greater than minus 87. Right? That means if I combine the two, I can say that r lies between minus 87 and minus 7. Second condition. Right? Both of these conditions have to be satisfied. Now, if both of them have to be satisfied, maybe I can have the number line, or if I can see the answer straight away, good for you. But I'll make the number line. Right? So, I will mark minus 87, then I'll mark minus 23, then minus 7, then 13. Right? Now, first is r is less than minus 23. So, either r is in this one. Less than, so obviously there's a hole over here. And r greater than 13. All real numbers go greater than 13. Right? First condition. Second, minus 87 to minus 7. So, here. So, here. Right? Now, I want r to satisfy this as well as this. So, that means r should lie over here and it should lie over here. So, that means the common part. So, that means I'm talking about this one. Right? No common part, no common part. So, this is the only common part. So, that means r must vary from minus 87 and minus 26. Right? Done? Now, my P and Q are fixed. My P is minus 87. My Q is minus 23. Just substitute it and you will get the answer as 64. Alright, on to the next question. Now he says the radii of two circles is 37 and 35. So 37 and 35. And he says PO. As in this length is given to you. Let K be the length of PT, which is tangent to the circle with center O dash, and points A, O dash, B, P. They are collinear. So that means they lie in the same straight line. Now he says write the value of K. So indirectly I need to find the value of tangent PT. Now, since tangent is getting involved, obviously I will join the point of contact with the center. And this angle has to be 90 degrees. If I'm interested in this length, that means I'll be working in this triangle as in P, O dash T. In this triangle, I know this length, which is the radius, which is 35. Since it is a 90 degree, that means I'll be interested in this length. Right? Then using Pythagoras theorem, I can find my PT. So my objective is to find the length O dash. In order to find this length is given to me. Obviously, I will join this one. Now, I'll be working in this triangle O dash P, in this triangle. I already know this length. I need to find this length. So somehow, if I'm able to ascertain this length, my problem is solved. And this length is easily visible to us. This length, let's say O dash, this length. Now, he says that O dash is the center of the circle, right? So that means this is my diameter. So this length is equal to this length, right? Now, consider the big circle. AB is chord of the bigger circle, and this is line from the center, and it is bisecting the chord. So that means this line has to be perpendicular. Class 9 here, right? Now, if this is 90 degree, I can easily find out this length. Why? Because if I join this is 37, this is 35, and using Pythagoras theorem, we know the Pythagorean triplet, that is 12. Right? So, O dash is equal to 12. Right? Now, go on to the bigger triangle, this one, the one we were interested in. Now, in triangle O dash P, I know the length OP, which is given to you, 2, 4, 5, 8. And I know this length O dash, which is 12. And I need to find this length O dash P, which turns out to be actually root 231. I think our job is done. If I know this length, I already know this length. Using Pythagoras theorem, again, we'll try to find the length of K. And the answer turns out to be 30. Alright, the next one. Now he says a 3-digit number ABC is called virtual prime. 3-digit number ABC is a virtual prime when if one obtains a 2-digit prime number by changing at most one of its units or 10th digits B and C. Right? Okay. So I don't understand this, but he has given us an example. He says 318 is a virtual prime because 17 is prime. Okay. Let me just analyze this. Now 318. Obviously, this is a 3-digit number. Now he says it is a virtual prime. That means I can obtain a 2-digit prime number. 2-digit prime number. So maybe I can have 11, maybe I can have 23, maybe I can have 73, and so on. Right? By changing at most one of its units or 10th digits B and C. So unit is 8, obviously 10 is 1. Right? By changing at most one of these. At most. Right? So either I can change none of these, or I can change one of these, right? Not both, because he says at most one, right? Okay. So now 1, 8. Now if I need to change one digit, which digit? He says you can change 8 to 7, right? 1 has, and we know that 17 is a prime number. If that is the case, that means such kind of number will be called a virtual prime, right? Okay. Now he says that alpha be the number of such virtual primes. You need to find the value of alpha by 81. So basically I need to find alpha, right? Okay. So basically I need to have 3-digit number. Now 3-digit number. Mind that there is no restriction on the first digit, right? We do not care about the first digit at all, right? So maybe I can put in 0. Careful. It's a 3-digit number. Obviously I cannot put in 0. That means either I can put in 1, 2, 3, 4, so on till 9. Right? I have 9 possibilities for the first one. Right? So I can fill the first place in 9. Right? Now corresponding to this, I need to decide this. Now this is the tricky part. Now he says you should have a 2-digit prime number by changing at most one of its unit or 10th digit. Right? I should get a 2-digit prime number. My 2-digit prime numbers look like, let's start with 11. Right? I have 11, I have 13, I have 17, I have 19, and so on. Mind it, 11, 13, 17, 19. Suppose I take the number 10, right? That's the least 2-digit number that I can think of, right? Now, if I'm taking 10, maybe I can change 0 to 1. If I change 0 to 1, I'll get the number 11, which is the prime number. That means I need to consider the number 10. Right? What about number 11? The next 2-digit number 11. I can take that. It itself is a prime. I don't need to change anything. Right? Next is 12. Mind it, obviously 12 is not a prime number, but I can change 2 to 3 maybe, or maybe 1, whatever you will like it. Right? If I change this number to 3, this becomes 13, which is a prime number. That means I will take 12. Obviously, I'll take 13. Again, 14 again, because I can change 4 to 1, 3, 9, whatever you like it, right? So I'll take 14. I'll take 15. I'll take 16, 17, 18, 19. Done? So 10 to 19, all of these two digits came. Okay, let me think about this 20 is like that. Now, prime number is 20, that is 23, then we have 29. Right? Let's start with, suppose we have moved on to 29. Now, let's talk about 20. If I replace 0 with 3, I'll get 23. Right? So, I'm getting a 2-digit prime number, so that means I'll take 20. 21. If I replace 1 with 3, again I'll get 23. That means if I take any number from 20 to 29, I can get either, I can make this or this. Right? Done? Now, let's talk about the next prime number, which is 31. And then we have 37. Right? So, again, I will cover up all the numbers from 30 to 39. Right? Similarly, I will cover all of the numbers from 40 to 49. Why? Because I can change one of the digits and I will get 41. Similarly, 50 to 59, 60 to 69, all of the 2-digit numbers are covered up. You take any 2 digits, you just need to change one of its digits and you'll get a prime number. Why? Because in all the 10s from 11 to 20, right, you have a prime number. From 21 to 29, you have a prime number. From 30 to 39, you have a prime number. Right? So in chunks of 10, you have a prime number anyways. So that means any 2-digit number you take, you will get a virtual prime. How many 2 digits are there? 2-digit numbers? From 10 to 99. How many 2-digit numbers are there? 90. Right? So that means I can have 90 possibilities for both of these places. Right? 90 possibilities. Now, obviously, since I know corresponding to each choice over here I have 90, here I have 9 choices. So in total, I had 9 into 90 choices, which is nothing but 810. This is the number of virtual primes. That is alpha. But I don't want alpha. I want alpha by 81. So divide by 81. Right? The answer is obviously in this case 10. On to the next question. In diagram, the rectangle is divided into 9 smaller rectangles. So you can say 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are the smaller rectangles. The areas of 5 of these rectangles are given. So area of this rectangle is 3, area of this rectangle is 1, area of this rectangle is 2, 5, 10. Right? Write the area of the rectangle labeled R. So that means I am interested in the area of this rectangle. Right? Now, area of this rectangle. I know that area of rectangle is length into breadth. Right? So as you can see, various areas are given and I can start by any of these. Now you will say, let's try to involve one variable, which is A, perhaps, or X, whatever you want to call it. But since I know that the answer will be a real number, instead of starting with the variable, let me just assume the length of the rectangle, right? So if I consider this rectangle, the area is 1, so I can consider the length and breadth to be 1 each. Right? I can do that because I just need to get the answer. Now, let me come to this rectangle. Now, I know since this length is 1, this length has to be 3. Right? Now, this length is 3, that means this length has to be 3. Now, the area of this rectangle is 5. If one of the length is 3, that means this length has to be 5 by 3. Right? Now, this length is 5 by 3, that means this length is 5 by 3. Now, come to this rectangle, right? The area is 10. If one of the length is 5 by 3, the second length has to be 6. Right? Okay, so that means for this rectangle, I already know one length. That means all I need to do is find out this one. This I can easily do it because this length is 1, this length is 1. That means since this area is 2, this length has to be 2. Right? For this rectangle, this length is 2, this length is 6. The area would be 2 into 6, that is 12. You can involve a variable also, that's also absolutely fine. Alright, for the next question, the figure is given to us. Now he says angle P is 90, PQ is 24, and PR is 32. Now since I know it's a right angle triangle, I know the third side, which turns out to be 40. Right? Even if you do not know the Pythagorean triplet, you can see that this is 8 into 3, this is 8 into 4, this has to be 8 into 5. right? Next thing he says M is the midpoint of RQ. That means this is equal to this. So dia is 40. That means this is 20. This is 20. Now he says NM is perpendicular to RQ. So this is 90. We are interested in the area of this triangle PNQ. This is a very special type of triangle. Why? Because it is a right angle triangle. The area for right angle triangle is nothing but half base. I can take PQ as a base into height. With regards to PQ as a base, my height would be PN. Right? Now I already know PQ, which is 24. Right? All I need to do is find out the value of PN. Right? Okay. Now PN is this length. In order to find out this one, I know that this is a right triangle. Right? That means if somehow I get to know this side using Pythagoras theorem, I can find out this one. That means I want NQ now. Mind it, NQ is also involved in some other right angle triangle, which is this one, NQ. Right? If I want to find out this value, this already I know, that means I want to know N. Right? Now, in order to find NM, I need to think about it. Now, NM is involved in this triangle, NRM. Right? What is so special about this tiny triangle? Right? Obviously 90 degrees is there. Also, it shares an angle with the bigger triangle. Right? 90, 90. Shares an angle. That means this triangle is similar to the big one. Right? Maybe I can use this. Now, let me write the similarity statement. So, triangle, I'll start with M because 90 degrees. MRN is similar to triangle. Now, corresponding to M, it has to be P, then R, then Q. Right? Now, I am interested in NM, so that means this one. So, MN divided by PQ, PQ. Do I know the length PQ, which is 24? Yes. Is equal to. Now, which length do I know? RN? No, I do not know. MR? Yes, I know. So, I will use this MR by PR. MR is nothing but 20 divided by PR, which is 30. Right? From here, you can get the value of MN, which is nothing but 15. Right? Now, this is 15. My job is done. Why? This is 15, this is 20. That means this is 25. So, I can shift it. Now, this is 24, this is 25. That means this is 7. Done? Just substitute it and you will get the answer as 84. Alright, on to the next one. Now, he says if polynomials this and this have 3 common zeros, then write the value of this expression. Now, obviously, if I can find out A, B, and C, my problem will be solved. Now, where is A? A is here, B is here, and C is here. Now, the condition given to us is polynomials have 3 common zeros. Mind it, this is a cubic polynomial, right? It will have 3 zeros anyway, and leading coefficient 1, leading coefficient 1. That means what? The factors must be like x minus alpha into x minus beta into x minus gamma. Right? And obviously zeros are alpha, beta, gamma. Now we know they have 3 common zeros. That means alpha, beta, gamma must be zeros of this polynomial. That means it will also have a factor of x minus alpha, x minus beta into x minus gamma and additional linear factor. Right? Mind it, these factors are already present over here. Can you see what is happening between the 2 polynomials? Right? We can clearly see that this polynomial will be exactly divisible by this one. Why? Because all of these factors are coming in the factorization of this. So this polynomial is divisible by this. Alright. So x raised to 4 minus 12x cubed plus bx squared plus 216x plus c is exactly divisible by this. So one way is I can obviously divide it properly, or I can just write it like this. I know that this is the dividend, so my divisor is that x cubed plus ax squared minus 18x plus 90. Now there would be some questions, right? Now obviously this question have to be a linear factor, x cubed, x raised to 4. So that means this has to be x, right? Up. Now I need linear factor, so that means I need the constant term. Mind it, here the constant term is c. Right? C. So obviously I would not want to write the constant term as C by 9. Why? Because fraction gets involved and we are not a big fan of fraction. So what I'll do is let the constant term be K, whatever the case may be. Yeah, we introduce one variable ourselves. It's okay. We'll find out the value of that one. Big deal. Right? Plus remainder of exactly divisible. So that means remainder is 0. Now, we know that this is a polynomial. This is a polynomial. Left hand side, right hand side polynomial. That means this corresponding coefficient should be equal. Now, obviously, the coefficient of x raised to 4 is 1. Coefficient of x raised to 4 is 1. Obviously, there is no condition there. Now, let's talk about coefficient of x cube, which is minus 1. Right? Coefficient of x cube. Now, mind it, we'll start with this one. X cube should be multiplied by k in order to get the coefficient of x cube, right? So that means here I'll get k. Then, let me see whether I can have x cube from here or not. X square x. I will get x cube. That means the coefficient is a. So, k plus a is my coefficient of x cube on the right hand side. Done? Now, let's move on to x square. The coefficient of x square is b. Now, coefficient of x square. Obviously, I will not start with x cube. I will start with x square. Now, this will need to be multiplied by the constant term. So, that is ak. Then, this one. This needs to be multiplied here. So, that means minus 18. This cannot be multiplied by anything. So, it's okay. Second relation I got. Right? Now, coefficient of x, which is 260, is equal to. Coefficient of x, I will not get from here. I will not get from here. Maybe I can get it from here. So that is minus 18k. Plus anything else from here. Yes, coefficient of x, so that means plus 90. Cool? Done. And last, obviously the constant term. Now, he says constant term is c. Here the constant term is 90k. Right? Using 4 relations, 4 variables are there. Let me find out the value. First of all, obviously I can see that k will turn out to be 7. Now k turns out to be 7, that means c turns out to be, k turns out to be minus 7. Here it is plus 90 or minus 90. Okay, wait. K turn out to be 7. Then, this is 90k, that is C. C turn out to be 630. Minus 90k क्यों आ रहा है मेरा? ये कैसे हुआ? Minus 90k के लिखा. K is actually turning out to be minus 7 from here. Yes. C will turn out to be minus 630. Perfect. B. Right. Now, instead of finding out B, I'll find out A. So, substitute K as minus 7. This will turn out to be minus 5. Substitute A and K over here. You will get B, which will turn out to be 70. You know the value of A. You know the value of B. You know the value of C. Just substitute it here and you will get the answer as 30. Alright. On to the next one. In square ABCD, CF bisects angles ACD. So that means this angle is equal to this angle. BQ is perpendicular to CF. So this 90 marked, right, etc. Now DQ is given to be 14. Then write the length of PE. So PE is here, right? So let me just try to remind myself the properties of the square, right? All the sides are equal. All the angles, they are 90 degrees. Also, the diagonals bisect each other. That means AE is equal to CE and BE is equal to DE. Right? Okay, so which property of square should I use? Right? Now, I can see that BE is equal to DE. This length is equal to this length. That means E is the midpoint of DB. Since midpoint is getting involved, might be, midpoint theorem might be getting involved. Right? It might be the case. Now, if I want to apply midpoint theorem, I have a midpoint, but I don't have any parallel line, right? I don't have any parallel line. So what I can do is, since I want to find out this length, and I have to make use of the fact that E is the midpoint, that means through here, I should have my parallel line. So what I can do is, from here, I can draw a parallel line. Since I have to make use of this 90 degree, I can draw a line parallel to PQ. Right, so from here, let me have a line parallel to PQ. So maybe it is something like this. Right, let this point be R. right? Now, what can you say about DR and RQ? I know that DQ, entire length is 14. But what about these individual lengths? Now, mind it, I have made sure that this ER is parallel to DQ, right? So, consider triangle DBQ. So, triangle DBQ. I can see that E is the midpoint of this side and this side is parallel to this one. That means R should bisect the third side, which is CQ. R should bisect, that means DR is equal to RQ. This I can say by converse of midpoint theorem, right? So that means this length is equal to this length, right? So entire is 14, this is 7, obviously this is 7. But I am interested in the length PE, right? I do not care about RQ. But mind it, I have not utilized the fact that this angle is equal to this angle, right? And I can see that here it is 90 degrees. And since these two lines are parallel, can I say that this angle is also 90 degrees, right? Okay. Now, if I look carefully, can I say that triangle CQP is isosceles? Triangle CQP is isosceles. I can clearly see it. This is the angle bisector, which is the perpendicular. This side, CQ, has to be equal to CP. Right? Also, if I consider this triangle, CRE, the big one, can I see that triangle CRE is also isosceles? That means CR is equal to CE. CR is equal to CE. But I am interested in PE. I have involved CE, I have involved CP, but I want PE. So that means I can subtract the two. Subtract the two. So I can see that RQ is nothing but PE. Now I want the length of PE. I should know the length of RQ. And I know that RQ is 7. So answer is 0, 7. Alright, on to the next one. He says write the number of pairs A, B of positive integers for which this equation is satisfied. Which equation? A cube plus 2AB is equal to 2030. Right? A, B and both are positive integers. This is a positive integer, this is a positive integer. Right? And I need the number of solutions basically. Now, mind it, here I have A cube and here I have 2013. This is a very small number because you know when we cube the numbers, it becomes very large very quickly. Right? So, let me see. Now, A is a positive integer, that means A, the minimum value of A which is possible, that is 1. Right? So, 1 plus 2 into 1 into B is equal to 2013. Right? That means when A is equal to 1, I will get some natural value of B. Why? Because this is 2012 divided by 2, that is 1006. So 1,1006 is one such ordered pair. Right? Then you can take A as 2. You will not get a solution here because I want A to be a natural number. Then A can be 3 and so on. Now you're saying, so what values do I have to check? Mind that this is 2013. I know that A, if I take A as 10, that 10 cube is 1000, okay. If that means 10 tak jaungi. Then A cube, 11. If A is 11, 11 cube is 1331, less than this. I can take A as 11. I can take A as 12 as well because that is 1728. But I cannot take A is equal to 13 because 13 cube is definitely greater than this one. Right? So in all, I just need to check what? From 1 to 12, just 12 possibilities. Right? That will hardly take any time. That is why the answer is 0, 3. Alright, moving on to the next question. Now he says two circles are tangent internally at P. The two circles, big circle and small circle. They are tangent at P. Alright, and the chord AB of the larger circle, so suppose my chord is something like this. Right? And we know that chord AB is tangent to the small circle. So obviously tangent at C. Right? He says PB and PA to join them. Done. PB and PA cut the smaller circle at E and D. So this is E and this is D. Cool. Now he says AB is 15. Cool. The entire length is 15. PE is 2. This tiny length is 2. And PD is 3. So this length is 3. Given to us. Right? We need to find AC. Mind it, AB is given to us. We need to find AC. Now, I need to find AC. Now, AC is the length of tangent from A, right? Okay. I need to find out this one. Entire length is given to me, 15. I need to find this. Now, the thing is, maybe I can find BC, right? But BC is also on the same footing as AC, right? Because it is also the length of tangent from outside, right? So, if I need to find AC, either first way is maybe I can try to find BC, or the second way is somehow if I can find out this ratio, AC-BC ratio, right? Then I can find out AC. So, I'll go with the second approach. If the first approach was not working, I was not able to find BC, then maybe I can find this ratio, right? So, if I need to find the ratio, what can I do? Right. So, I need AC. So, let AC be X. Obviously, this becomes 15 minus X. Right. Now, in this question, we have tangents and we have secants. Now, we have tangent, we have secant. Obviously, we can use PT square is equal to PA into PD. This theorem, I hope you remember this. Now, in this case, AC is the tangent, so AC square is equal to AD into A. AD into A. Right? Written down. Done. Now, obviously, BC is the tangent, so I can say from here, BC square is equal to BE into BP. BE into BP. Right? Now, the thing is, I was interested in this ratio, AC ratio BC. AC ratio BC. Let me divide the two. Let's see what happens. Right? So, AC square, I'll say X square, whole divided by 15 minus X whole square. Right? That is equal to AD by BE is equal to AP by BP into AP by BP. If I can find out these ratios, my problem will be solved. Now, out of these, one ratio is easily visible to us. This one. Till now, we have not utilized the fact that this is 2, this is 3. Also, we have not utilized the fact that these two circles are touching each other internally. How do I make use of the circles which are touching internally? Right? Whenever they are touching, that means there is a common tangent. Let me draw the common tangent. At this point, I will have my common tangent. Right? My common tangent. How can I use this common tangent? Mind it, this is a tangent to the bigger circle, right? And this is the chord of the bigger circle again. That means this angle would be equal to angle in the alternate segment. So, two segments, this and this, alternate one, so that one. So, if this is theta, this will be theta. Whatever results I know, let me just use them. Let's see what happens. Right? Also, same thing, this is a tangent to the smaller circle. This is the chord of the smaller circle. So, let me join these two. Right, chord of the smaller circle. Now, angle between tangent and chord should be equal to angle in the alternate segment. I can see one segment, two segments. So, here, the alternate segment is this one. These two angles would be equal. If this is theta, this is theta. Right? Wait a second. This is theta, this is theta. What can you say about these two lines? They are definitely parallel. Observation. Okay. Whatever I know, I have written it. But since I'm interested in the ratios, right? Maybe BPT can be used, maybe similarity can be used, I don't know. Now, BPT will be used when there's a parallel line. I can see it if these two lines are parallel. Now, if these two lines are parallel, that means this by this is equal to this by this. Let me write it. So, PD by AD is equal to PE by B. Right? Is there a benefit to this? Let's see. If these two ratios are equal, can I say that this ratio will also be equal? PD by PE would be equal to AD by PE. Just cross multiply. Nothing more. Why am I interested in this one? AD by BE? Oh, AD by BE. That's right. Now, do you think I have the value of AD by BE? Let's see. PD by PE, pata mujhe? Yes. PD 3, PE 2. So that means this ratio is nothing but 3 by 2. Right? So at least I know this one ratio at least. 3 by 2 into. Somehow, if I can find out this one, my problem is solved. Right? My problem is solved. AP by BP. AP by BP. Interesting. AP AP by BP. Mind it, AP. How have I got an AP? By adding this portion and this portion. PD and AD. If I add the two, I'll get AD. Wait a second. PD and AD, if I add the two, I'll get the bigger portion. Fine. Also, I want AP ke saath BP. So, BP, I need PE plus BE. PE plus BE. If I add these two and add these two, I'll get the required ratio. Now, I know the ratio property is PD by PE is equal to AD by BE. This ratio is actually equal to PD plus AD. Ratio property is that. Whole divided by PE plus BE. Right? And this is nothing but AP. And this is nothing but BP. Done? Now I know this ratio. We know PD by PE, that is 3 by 2. This is 3 by 2, 3 by 2, 3 by 2, 3 by 2. Done? AP by BP is also 3 by 2. AP by BP, 3 by 2. I think our problem is solved. Why? Because right hand side actually becomes 3 by 2 whole square. So, I don't even need to write this, that you can evaluate. So, AC square by BC square is actually 3 by 2. That means AC by BC turns out to be 3:2. 3:2. You know the entire n to be 15. You can use the quadratic, solve it, or you can see the answer. 3:2. That means this is 9. This is 6. I want to let AC. The correct answer in this case, that is 0. Alright, the next one. Now it says write the number of integral solution of it. Now, integral solution of it. Now, y quadratic, my next, and then quadratic in y, right? So, I do not know how to solve the equation as it is, but he says you don't need to talk about all the solutions, just the integral solution, right? Now, if I look carefully on left hand side, I can see the factors as y into y plus 1. Why are we going for the factors? Any solving of the equation requires factorization, right? So, whatever I can factorize, I will factorize. On left hand side, if I take x common, and that will be left with 1 plus x square plus x cube. Again, this is factorizable. This is 1 plus x into 1 plus x square. Right? So, I have these 9 factors. Now, integral solution. First of all, let me write the obvious one. Right? Which will make left hand side equal to right hand side. Obviously, which will be, I will try to make this as 0 and this as 0. Now, if I put y as 0, right, y as 0, so this becomes 1, nobody cares. Now, x will be, I can put x as 0, or I can put x as minus 1 also. Why? Because if I put x as minus 1, this term becomes 0. So, I can do this also. Right? Now, taken y as 0. Now, if I want to make this as 0, I can put y as minus 1 also. So, if I put y as minus 1, this thing becomes 0, nobody cares about this. This is minus 1, we care. Right? Now, right hand side 0, so obviously I can put x as 0, 1 case. Or I can put as x as minus 1. Right? The obvious one, so I can say. Now, the problem is, what about the non-obvious one? Let's see. So, y into y plus 1 equal to x into 1 plus x into 1 plus x. Now, if I want to look ahead, what I can do? Maybe I can put x as 1. Let me see solutions in positive integers first. So, if I am putting x as 1, get 1 into 2 into 3. Right? Into 2 in fact. Yeah. And this is y into y plus 1. Now, the thing is, this is 4. Can you think of splitting 4 as product of 2 integers and 2 consecutive integers? I can't do that because 4 I'll write. I'm just talking about the positive one. 1 into 4 or 2 into 2. Again, positive consecutive integers are not there. So, this is not there. Then I can put x equal to 2. If I put x equal to 2, y into y plus 1 is 5. This becomes 2 into 3 into 5. Now, this is a nice thing. Why? Because this is 30. 30 I can write as 5 into 6. Right? So, if I do that, I get x as 2. Along with that, I get y as 5. Or, the second case is y as minus 6. Yes. Right? Again, the obvious one I'm getting. Now, next, let's move ahead. X equal to 3. Y into y plus 1. This becomes 3 into 4 into 10. Now, if you look carefully, here consecutive integers are there. And this number is 12 and this number is 10, right? No, not product of consecutive integers, so I will reject it. Now, when I put x equal to 4, this becomes 4 into 5 into 17. So, this is 20, this is 17. Again, product of not two consecutive integers. In fact, the difference between 20 and 17 is 3. Alright, not the 1. X equal to 5. Then I write 5 into 6 into 26. Now, 30, 26. In fact, if you notice, here consecutive integers are not there. In fact, the difference is 2. Then the difference is 3. Then the difference is 4. And if you go forward, you can see that the difference is increasing. So that means the nearest two factors, in fact, they are going apart from each other. So that means ahead I will not get any solution. Now you can say, what about in the negative integer side? You can do that. Now x equal to minus 1, I've already written. X equal to minus 2. Right? If I do that, x equal to minus 2, y into minus 1, as it is equal to. This is minus 2. This is minus 1, which becomes positive and 5, but okay, fine. And this becomes 5. Again, the problem is the same. Here I have 2 into 5, 10. Again, I cannot write it. Then I put x equal to minus 3. So y into y plus 1, minus 3. So minus 3. Then I will do minus 2. And then I will do 10. Again, that is 60, 60. The nearest one is in fact 10 into 6. 10 into 6. Again, you can see, here the difference was 3. Here the difference is 4. It will keep on increasing. The nearest two factors will have difference increasing. I will not get the product as two consecutive numbers. Right? So that means the only possible solutions are these. And the answer is 0. Alright, on to the next one. An inverted right circular cone of height 25 centimeter is filled with oil up to half of its height. First of all, I am talking about the inverted cone. So it looks something like this. It is half filled with oil. Second inverted cone, yes. First of all, height is 25. Half filled is filled with water up to half its height. So this is my oil. And suppose this height has to be 25 by 2. Right, the oil is dripping from a hole in the tip. So obviously oil is leaking out from here, as you can see. Initially, the upper surface area of the oil. Initially, upper surface area. Where is the oil? Oil is here. What is the upper surface area? Oil is here. Upper surface area is this one. This area is given to be what? 154 centimeters square. Right? Okay, let's move on. Now he says after 49 minutes, since the oil is coming out, the height of the oil becomes half of its original height. So after 49 minutes, half of its original one. So now my oil is here. Right? This height is 25 by 4. Why? Half of this. That is 25 by 4. And now he says the upper surface area. So oil is here, upper surface area is this one. This is how much? This is 77 by 2. And this all happens in 49 minutes. Now what happens? Oil from a cylindrical beaker of diameter this and height this is poured into the cone. In how many more minutes will the cone be emptied out? Right? Now, if I need to empty out the cone, I need to empty out this oil which is left and the additional oil that I poured. Right? Okay. Now, what do I know? That what happened? The oil which leaked out, which is this one, in 49 minutes. So, how much volume of oil dripped out in 49 minutes? Let me find out. So, this is the volume of the oil, right? This is nothing but the volume of the bigger cone minus volume of this red cone, right? The volume of the bigger cone. So, I know that is 1 by 3 pi r square h. Now, pi r square, because this is the area of the circle which is given to you, that is 154, right? Into h, height is 25 by 2 minus the volume of the smaller cone, which is 1 by 3 into. Now, this area is already given, so 77 by 2 into the height, which is 25 by 4. Right? This much volume was dripped out, or it was let out in 49 minutes. right? Now, how much volume has to go in order to empty out the cone? First of all, this much volume. So, this is what? Volume of this cone, which is nothing but 1 by 3 into 77 by 2 into 25 by 4, right? Plus the additional oil that I poured from the cylindrical beaker. Now, volume of the oil in the cylinder would be equal to the volume of the cylinder. So, plus additional oil that I need to empty it out. Volume of the cylinder, which is pi, 22 by 7, into R, which is diameter is 3.5, R is 3.5 by 2, R square, so 3.5 by 2 again, into height, which is 25. Right? Now, it took 49 minutes to empty out this. I need to empty out this much of water, oil, right? So, as you can see, this and this, they are directly proportional, right? This and this, they will be directly proportional, right? Or I can say, this is in direct variation or this is in direct variation. So, this thing divided by this is equal to this time I need to find out. This by this is equal to this by this. You can see the rate at which it is being emptied out is uniform. That is why I am saying it is in direct variation. Right? So, you can find out, you can consider this to be x. You just need to divide it. You are brilliant at calculations, hopefully. And the answer turns out to be 28. Alright, on to the next one. Now, he says the base BC of triangle ABC is divided at D so that BD is equal to 2DC. So, let me make the figure side by side. Right? Now, A, B, C. Now, BC is divided so that BD is equal to twice of DC. Okay. Right? So, this is twice of this. So, if this is x, this is 2x. Right? So, basically, I know this ratio 2 is to 1. Maybe I can use that. BD by BC is 2 is to 1. Right? On BC, on the side remote from A, that means not on this side, a semicircle is drawn, right? So, on BC, semicircle, but this side, so maybe this is the one, right? This is a semicircle, that means BC is the diameter. Now, he says through D, draw DE at right angle to BC to cut the semicircle in E. So, from here, I need to make a perpendicular to the circle, which meets the circle at E. This is 90 degrees. Alright. Now he says from BC, cut off a part BP equal to CE. Now CE length is this now. Now he says from BC, from here I need to cut off a part BP which is equal to this one. So I'll measure this and cut it over here. Suppose it turns out to be this one. We know that BP is actually equal to CE. Done. Now, he says draw PQ parallel to CA, where obviously Q is on BA. So, this parallel to this, so it is somewhat like this. Yeah. So, this parallel to this. Done. Now, he says if area of triangle ABC, as in this entire area is 72, you need to find out the area of BCQ, this area. Right? Now, mind it, since these two are parallel, can I say that this triangle is similar to the big one? Right? Triangle BPQ is similar to triangle BCA. Right? If I know the bigger area, I can find the smaller area, provided I know what? The ratio of the sides. So, I should know, maybe I should know BC by BC, maybe I should know BQ by BA, maybe I should know QB by AC. Now, my guess is I will get to know BP by BC. So, all I am interested in finding out the BP by BC ratio. Right? Now, here, wait a second. He says BP is equal to CE. That means maybe somehow I can find CE by BC. Maybe. We don't know, but maybe. Which is a very peculiar thing. I need to find this by this. In order to find this. Now, what do I know? What I can utilize over here, right? Mind it, I need to use this 90 degree. Mind it, I have to use of this fact that this is a semicircle. Now, semicircle, what is the property? That angle in a semicircle is 90 degree, right? So, maybe if I can join this, right? this is obviously 90 degrees. That means BEC is a right triangle and this is actually the altitude. Maybe I can use that. Also, till now I have not utilized this back 2 by 1. This is 2 is to 1. So maybe if this length is 2x, this length is x. Right? Okay. What else can I use? Now, this is 90, this is 90. We've already proven so many times that DE square is equal to BD into CC. Right? Using similarity, we can do that. So that means DE square will turn out to be, this becomes 2x square, so this becomes root 2x. Whatever length I get to know, I'm just writing it down. Right? This is root 2x. Mind it, this is x, this is root 2x. That means CE is nothing but root 3x. I think our problem is done now. Look, CE is nothing but root 3x. BC, the entire thing is 3x. So that means this ratio is 1 by root 3. Right? This ratio is 1 by root 3, that means BP by BC is 1 by root 3. Right? BP by BC. Now, since I know the ratio of corresponding sides, can I find the ratio of the areas of similar triangles? Even if you do not know, within 10 seconds I can derive it. Right? The ratio of the area would be nothing but, I am writing it here, area of BPQ whole divided by area of ABC would be nothing but 1 by root 3 whole square, which is 1 by 3. Now, if this is given to be 72, this will turn out to be 24, which is the answer. Alright, on to the next one. Now, he says write the sum of digits of a 4-digit number, which is a perfect square, such that its first 2 digits are equal to each other and its last 2 digits are equal to each other. Right? First 2 are the same and then last 2 are the same. And the number is a perfect square. Now, I know that any perfect square will either end with 0 or 1 or 4 or 9 or 6 or 5. Right? So that means at these two places, so a unit place can be 0 or 1 or 4 or 9 or 6 or 5. Right? So let me start with the 0, 0 case. Right? Because if this is 0, this has to be 0. Condition is given. Now, first 2 digits are equal. So that means, obviously it cannot be 0, 0. It can be 1, 1. No, I know this is not a perfect square. Right? Because the thing is, it's 0, 0. So that means it would be a square of like 30 square or 40 square or 50 square. Right? Now, 11 is not a perfect square. Right? 12, 22, again, not a perfect square. 33, no. 4, 4, no. 5, 5, no. 6, 6, no. 7, 7, no. 8, 8, no. 9, 9, no. These are anyways rejected, I don't even need to check it. Right? So that means my 0 case is done. Now let me take 1. Right? Now mind it, I know it's a perfect square question, right? In class 10, we have studied that any squared quantity is either of the form 4k or 4k plus 1. Right? The number which has 1, 1, that means it is of the form 4k plus 3. Right? Definitely this number cannot be a perfect square. Done? So that means even 1, 1 is rejected. So let's come to 4. Right? This I need to check. So first, obviously, I'll check for 1, 1. It's not. Then you can check 2, 2, 2. Again, it is not a perfect square. Then 3, 3, 4, 4, not a perfect square. 4, 4, 4, 4. This is definitely not a perfect square. Then 5, 5, 4, 4, not a perfect square. 6, 6, 4, 4. You need to check these. Not a perfect square. 7, 7, 4, 4. You will realize it that this is nothing but 11 into 8. 88 whole square. Right? So that means this is the required number. He says write sum of digits. Sum of digits will obviously be 22. Alright, on to the next one. Now, for the sake of conserving time, I have made the figure for you. Now, he says in triangle ABC, BD is equal to DE is equal to EF is equal to FC, and then CG is equal to HG is equal to HA. It is given to us. And BQ is given to be 10, as in this length is 10. He says, I want to find out the length PG. Right? Now, I'm interested in this length, and I need to use the equality of so many lengths. Now, equality of so many lengths, then it comes like this. Now, immediately my mind goes to midpoint here. right? Because so many midpoints are there. If I look carefully, I can see that E is the midpoint of EC, right? So maybe I might be able to utilize that. But in order to apply midpoint theorem, I should have nicer triangles. So what I'll do is I will try to join the 90 points. Now, first of all, if I join F and G, right, and I will join E and H, I will get some set of parallel lines. Why will I do that? Why? Because now, look carefully. F is the midpoint of EC and G is the midpoint of HC. This by this, in fact, instead of midpoint theorem, I can use basic proportionality theorem also. This by this is equal to this by this in triangle ECH. This is the midpoint, this is the midpoint, so that means these two lines are parallel. Alright. Also, now if I consider this line, I think this line is also parallel to something. Now, let me consider the big triangle ADC. Now, triangle AB. Now, if you can see that this ratio, this is 2, 1. So, 2 is to 1 and this is also 2 is to 1. So, that means this line is parallel to this line. So, EH is parallel to AB. Right? So, these three lines are parallel. I might be able to use it. But my problem is to find out this line. PG. This entire length. Out of this entire length, I know some length at least, some length. If I name this point as S, do I know the length FG? This much I know. No? Right. Consider this triangle BFG. This. This is parallel to this. This is parallel to this. Can I say this by this is equal to this by this QS by HG? So if this is 10, this is 10, this is 10. So I know this part which is 10. Right? If I want to find out PG, I need to find out this tiny length, PS. In fact, I'll write S here. So this entire baby length, how will I find that out? Also, I know that this entire length is QS. So I want this tiny length. So now if I know the ratio of this QP by QS, then I can divide 10 as something by something and I will get to know PS. So now I am interested in this ratio, QP ratio. Now ratio, this by this is getting involved in this triangle and this is getting involved in this triangle, this side. Now ratio of the sides of triangles will be involved provided these two triangles are similar. Which they are, right? Because this angle is equal to this angle and vertically opposite angle. So I can say triangle APQ is similar to triangle EPS. Right? Okay. So if I want to find out this by this, so maybe I can find this by this ES by QX. You can see that also ES by QP. Q. This will be equal to QP by PS. In fact, I have written it opposite, so this will be equal to PS by P. Now, the question is, I have reduced my problem. This by this is this by this. How do I find out this length? This and this. In fact, I don't want the length, I want the ratio. Ratio. How do I? Now, mind it, I know that this length will be associated with this one, right? And this one will be associated with this one, the entire. Interesting. This will be associated with this one. So, what I'll do is, I'll suppose this length will be 2s. Is that fine? Now, if this length is 2s, I can apply similarity in this bigger small triangle and the bigger one. I can find that out with 3. Why? Because this by this is 2 is to 3. So I will leave that up to you. Now, if this length is 3x, I want to find out this length. Directly I can do that. Because this tiny triangle is similar to this one. Right? This by this is nothing but this by. So 1 is to 3. So this is 3x. This entire length is 9. My point was not the entire length. I just wanted this one. So this portion is left. Let me see this portion. Now let's come to the smaller one. This triangle, this baby triangle, is similar to this bigger triangle. So this is 2x, that means this length is 2x. This entire length is 9x. This baby length is x, so that means this length is 8x. If this is 8x, this is 2x, so that means I need the ratio which I get as 2 by 8 as 1 by 6. Is that fine? Now I need to divide 10 in the ratio 1 by 4, so obviously I will write 3 as that 2. And PS is 2, this is 10, that is why the correct answer is. Alright, on to the next one. Let A be the set of all integers n for which this is a perfect square. Then write the sum of all elements of A. Basically, I need to find all possible values of n such that this becomes a perfect square. Right? Now, minus n square plus 19n minus 74 has to be a perfect square. That means this quantity has to be of the form k square maybe. Right? Now, how do I deal with that? Now, this quantity is k square. What I can do is, I can shift everything to that side. I'll get n square minus 19n plus 74 plus k square. This is equal to 10. Right? Now, mind it, I need to find integral n. Integral n. Now, can I find the value of n from here? Yes, ma'am. It is a polynomial n. I can find the value of n by what? By using quadratic formula. Right? I can write 19 plus minus 19 square minus 4 into 74 plus k square. Why? Because this entire thing is c. Careful. Whole divided by 2. Right? Now since n is an integer, now this is an integer, this quantity has to be an integer. Then now you want the square root thing to be an integer. That means quantity inside the square root should be a perfect square itself. So 19 square minus 4 into 74 plus k square has to be a perfect square. Right? So let me see. 19 square, that is 361 minus this is 296 minus 4k square. This quantity has to be a perfect square. Right? Now, a perfect square, that means, okay, not the 2 because I want to imagine it, so maybe it will be of the form n square. Right? Now, if I shift this to that side, I'll basically get n square plus 4k square is equal to 65. Now, 4k square is nothing but 2k whole square. Now, you are saying sum of two squares is equal to 65. Very less cases are there. One will be 64, the other one will be 1. Then one will be 36, I guess. The other one will be 49. No, one will be 16, the other will be 49. Right? I don't think you'll have more cases. So, you have different values of k. Corresponding to that, you can find the value of n. And you will get the answer at whatever elements would be there. The answer will turn out to be 38. Mind it, you can do easily, you can have the method of hit and trial in this question. You can just put in the corresponding value of n. Because n is an integer. Start putting it. You know, because after a certain point of time, you will stop getting the perfect square. So, if you have time and you are unable to think of this method, you can use hit and trial also. Alright, so the next one. A multiplicative partition of a positive integer n greater than or equal to 2 is a way of writing n as product of one or more integers. Right? Way of writing product of one or more integers, each greater than 1. Note that we consider positive integer to be a multiplicative partition of itself. That means if I have the number 25, the multiplicative partition 25 would also be there. Right? Also, the order of the factors does not matter. Suppose in a multiplicative partition, 2 into 3 into 5 is there and 3 into 2 into 5 is there. Now, order does not matter. These are considered to be same. Right? For each positive integer n greater than or equal to 2, define P of n to be the number of partitions possible. Right? Okay, P of n. So, P of 40 is given to you, which is equal to 7. That means number of partitions That means number of ways of writing 40 as product of one or more integers, that is 7. And he has given that. First one is 40, right? Second is 2 into 20, then 4 into 10, then 5 into 8, then 2 into 2 into 10, 2 into 4 into 5, then 2 into 2 into 2 into 5. So you can see that these are 7 in number. So basically you need to write 40 as product of one or more terms. So one product of just one term, product of two terms, product of two, product of two, product of three, product of three, product of 4. In fact, if you notice, he has already given us how to count the cases, right? Our question is write P of 800. That means you need to count in how many different ways can you write 800 as product of numbers. So my number is 8 now, 800, right? So let me try to write it. So obviously 800 may the multiplicative partition would have 800. Then you can see first I'll write all the product of two numbers, right? That means ways in which I can express 800 as product of two numbers. So I can start, that is 2 into 400. Then I can have 4 into 200. Then I can have 5 into 160. Then obviously 6, 7, no, 8, yes, 8 into 100. Then I can have 10 into 80. Then I can have 16 into 20, 16 into 10, no, 16 into 50, of course, right? Then I can have 20 into 40, right? Then I can have 25 into 32, and then I will start repeating it, right? Because 32 into 25, again, ordering does not matter, so I've already written it. So first I wrote product of one term, that is this. Then I wrote product of two terms. Then I can go for product of three terms. Product of three terms, so I can write 2 into 2 into 200, right? Maybe then product of 3. So then I can write 2 into 4. I can take 2 from here. 4 into 100. Then I can take 2 into just 3. 3 you need to write it, right? So 2 I can take, so 8 into 50 and so on. In this way you have to write each and every case. Right? Now you know that the answer lies between 0 and 99. That means there cannot be more cases than 99. Right? Because he directly asks you the number. Right? So, provided you have the concentration, provided you do not miss anyone, provided you do not over calculate, because sometimes you count the cases twice. Provided you don't do that, you will get the answer as 47. You know the method, just write down product of two numbers, product of three numbers, product of four numbers, product of five numbers, and so on. Alright, let's move on to the next question. Now this next question is precisely the kind of thing that you should do in test papers. That means just read the question carefully and answer it. That's it. Alright, so let's just see. He says for each positive integer n, an even sequence from this set is defined to be a sequence that satisfies the following conditions. What are the conditions? Each of the terms is an element of the set. Right, so obviously I will be using numbers from the set itself. Then the sequence has to be increasing, right? So that means the sequence might be 1, 4, 5. But do you think the sequence can be 2, 3, and 1? No. This case the sequence is not increasing. Right? Okay, so we understand the meaning. Then also he says that terms in odd number position are odd, and terms in even number position are even. Right? So any sequence, if I take any sequence, I can see that this is the first place, this is the second place, this is the third place, this is the fourth place. So first place, it's an odd number, right? So that means odd numbers would be there. So I can put in 3, right? I cannot put in 2 here, right? This is a position second, that means even position is there, so that means maybe I can put 4, right? Then third, again odd, so maybe an odd number, so maybe 7, and so on. Right? Now he is saying an even sequence from this R. Now he says, now first one is 1, right? Just 1. Now since 1 just have one position, odd number is there. Since 1 is there, so automatically, trivially it is increasing sequence, and obviously element is from the set itself. All the 3 conditions are satisfied. Second is 3, same goes. Third is 1, 2. Now first odd, second even. Increasing? Yes. Then 1, 2, 3. Odd, even, odd. Increasing? Yes. Right? Now he says, your job is to find the number of even sequences from this set. Right? Okay. So I have this set. That means I'll be using the numbers 1, 2, 3, 4, 5, 6, 7. Right? Now as you can see, number of even sequences. So I can make cases on the basis of the length of sequences. Whether one element is there, whether two elements is there, whether three elements is there, 4, 5, 6, 7. Right? And obviously the sequence will not be longer than 7 elements. Right? So let me just try to do that. So first case is one element sequence. Right? Obviously one element, so one place, and this is first place itself, so that means only odd number will come. So I can have 1, then 2 I cannot have, I can have 3, then 5, then 7. Done? Exhausted. One element sequence is done. Two element sequences. Right? Now 2 elements are there, that means first odd, so odd number should be there, second even number should be there. Also the sequence has to be increasing, so I have to be careful. Right? First odd is there, so let me start with 1. Now second even, so I can have 2. Then maybe instead of 2 I cannot have 3, maybe I can have 4, so 1, 4 is there. I cannot have 1, 5, I can have 1, 6 though. Done? Sequence is starting with 1 exhausted. Now odd lena, so I will start with, I cannot start with 2 because I need an odd number, 3. Right? Now I can't write 3, 2 because the sequence would be decreasing then. So 3, 4 would be there. 3, 5, no. 3, 6, yes. 3, 7, absolutely not. Right? Then obviously I cannot have a sequence starting with 4. I have to start with 5. So 5, 2 I cannot write, 4 I cannot write, so 5, 6. Done? Now I cannot have a sequence starting with 7 because I don't have a number to write in the next place. Right? So these are the 2 elements. So how many these are? These are 6 in number. And these were 4 in number. Right? Similarly, you can write 3 element sequences. Right? So 1, 2, 3, that means odd, even, odd. So I will start with 1. Right? Then I can have 2, then I can have 3. Right? So 1, 2, 4 I cannot, so 5. Then 1, 2, 6 I cannot, 7. Done? So 1, 2 exhausted, so 1, 4 I can go. So 1, 4, 5. 1, 4, 7. Just write it down. You know how to write it, right? 1, 4 exhausted, so I can have 1, 6, then 7. Now, sequence is starting with 1 exhausted, so let me write with the 2, so starting of the case is 3. 3, 4, 5. Then 3, 4, 7. Done? 3, 4 exhausted, I can have 3, 6, and then that will be 7. Done? Sequence exhausted with the 3 as the first one. Done. So I will go to 5. So 5, 6, 7. That's it. I cannot start the sequence with 7. It's very obvious. That's it. 3 element sequences would be 3, 3, 3, 10. Similarly, you will write the 4 elements, 5 elements, 6 elements, 7 elements. Provided you have good concentration, you will have the correct answer, which turns out to be 33. Alright, on to the next one. Now he says if n is the number of ordered pairs of positive integers a, b, such that the LCM of the two numbers is this, then write the value of n by 45. So basically I need to find the number of ordered pairs a, b such that the LCM is this. Right? So LCM is given to be 2q into 5 raised to power 7 into 11 raised to power 30. Right? I need to find the ordered pairs a, b. Mind it, LCM is given to us. Lowest common multiple. Right? Okay. Now we need to talk about a, b. The possible values of a and b. Mind it, a can have a factor of 2. Right? And maybe some power of it. Okay. Along with this, it can have a factor of 5. May or may not have. Right? 5 or 100 powers and 11 100 powers. Right? Other than these 3 prime factors, there is no other possibility for another prime factor, right? Because it would have otherwise dropped up in LCM. So that means the only prime factors in A that can be there is 2, 5 and 11. Maybe all are there, maybe 1 is there, maybe 2 is there, right? Okay. Now, B, obviously it might have a power of 2, it might have a power of 5, it might have a power of 11. Other than these three prime factors, there is no other possibility. So if I need to find out the number of ordered pairs, I need to find the different powers of 2, the different powers of 5, the different powers of 11. Right? Now he says that LCM is 2 raised power 3 into 5 raised power 7 into 11 raised power 13. Right? Now let's go back to junior classes. How do I get this 2 raised power 3 in the LCM? Mind it, I am talking about the lowest common multiple. Right? So suppose I have a number where the power of 2 is 2 and the other power is 2 raised power 3. So in the LCM, I would have 2 raised power 3. I'm not talking about the other prime factors which are there. I'm just talking about a single prime factor and its power. Right? Another case, let us take power 3. Suppose one power is 4, the other power is 7. In the LCM, I would have 3 raised power 7. Right? The higher of the powers goes. Now he says in LCM I have 2 cube, 2 raised power 3. That means the higher power has to be 3. Either it can be here or it can be here. Interesting. So let me talk about powers of 2 only. Powers of 2. Right? So A and B. Powers of 2. Right? So maybe A has the highest power, which is 3. Corresponding to this, there might be a case where B does not have 2, any power of 2, right? It can be there. Because if I have 2 raised power 3 and 2 raised power 0, obviously in LCM I will take 2 raised power 3. Cool? Right. Now, again, let the power of 2 be 3, but corresponding to this, let the power be 1. LCM would have 2 raised power 3. Another case. Then 3, 2. LCM would have 2 raised power 3. Then 3, 3. Right? In this case, the highest, obviously they are the same, the highest would be 3. Done? Now, you think I can have 3, 4. Mind it, if I do that, my LCM would have 2 raised power 4, but my LCM has 2 raised power 3. That means this power cannot exceed 3. Right? So maximum 3 can be there. Mind it, I am interested in the ordered pairs. Right? So that means I can have 3 over here and 0 over here. Right? I can have 3 over here, 1 over here, 3 over here, 2 over here, 3 over here, 3 over here. This I have already written. Don't write it again. Careful. Right? So these are the corresponding powers of 2 which are possible. Right? As you can see. Corresponding. I've written it. Yeah. 2 raised power 3, 2 raised power 2, 2 raised power 3, 2 raised power 3, then 2 raised power 0, 2 raised power 3, then 2 raised power 1, 2 raised power 3, 2 raised power 2, 2 raised power 3. Right? That means these are the corresponding powers of the 2. Now, either this will happen, this is one case only, or this will happen, or this will happen, or this will happen, or this, or this, or this. That means among these 7, there has to be one possibility. Right? So first I need to talk about powers of 2. Powers of 2. How many possibilities do I have? I have 7 possibilities. Right? Other than these, I cannot have any possibility. Interesting. Now, let's talk about power of 5 then. Right? So I will erase this now. Let me talk about power of 5. Now he says my LCM has 5 raised power 7. That means the highest of the powers is 7. Right? Maybe A has 7. Corresponding to this, maybe the power here is 0. So that means 5 raised power 7, 5 raised power 0. Another case, 7 and 1. As in 5 raised power 7, 5 raised power 1. Right? Next 7, 2, 7, 3, 7, 4, 7, 5, 7, 6, 7, 7. Now obviously I cannot go 7, 8. I need to reverse it now. 7, 0, 7, 1, 7, 2, 7, 3, 7, 4, 7, 5 and 7, 6. Right? Either this case will happen or this or this or this. And how many cases these are? These are 15 in number. Right? So that means powers of 5. They can be arranged in 15 ways. Last is powers of 11 that you will find out for your own good. Right? That is powers of 11. Right? This will actually turn out to be 27. Right? Here I have talked about the powers individually. I I need to make a number, right? Now, parts of 2 can be arranged in 7. Now, I need to arrange parts of 5 also corresponding to this, right? I need to arrange parts of 11 also corresponding to this. I think answer is there. Number of quadrants is 7 into 15 into 27. Right? That is equal to n. But I do not want n. I want divide by 4. Right? You can divide it, and that is why the answer for this question turns out to be 63. Right. On to the next one. Now he says, consider a set S that contains m greater than or equal to 4 elements. Right? So that means number of elements should be greater than 4. It can be 4, greater than or equal to 4. It can be 4, it can be 5, it can be 6, and so on. So we're talking about such a set. And obviously each of these numbers is a positive integer. Right? And since it is a set, obviously the numbers cannot be equal to one another. The numbers have to be distinct. So that means 4 elements, all 4 numbers have to be distinct. 5 elements, 5 numbers have to be distinct. Right? Now he says we call S boring if it contains 4 distinct integers a, b, c, d, such that a plus b is equal to c plus d. That means we'll call a set boring if I can find out 4 integers out of it, such that sum of 2 is equal to sum of other 2. Right? He has given us as an example also 2, 4, 6, 8, 10 is a boring set. Why? Because 2 plus 8 is equal to 4 plus 6. We have found out 4 numbers here over here such that sum of 2 is equal to sum of other 2. That is why this set is boring. Right? Now he says we call S exciting if it is not boring. That means if you are unable to find 4 integers such that sum of 2 is equal to sum of other 2. So in exciting, those two sums will not be equal. So this one, obviously you take any number, sum of any 4 numbers, sum of 2 will not be equal to the sum of other 2. Done. Now on to the actual question. He says write number of 5 element subset. 5 element subset. So maybe I can have 2, 3, 5, 6, 7. Right? But we need to have only those subsets which are exciting. That means sum of 2 integers should not be equal to sum of other 2 integers. I have to make sure of that. Now, sum should not be equal. How should I start the question? Now, sum should not be equal. Condition is there on the sum. So maybe I can find out the possible sums first. Right? Maybe the sum of numbers can be 11. Maybe the sum of numbers can be 5. Right? So maybe let's write all the possible sums that are there. So suppose we are talking about the sum 3. Right? Now, possible pairs along with it. Now, 3 obviously can be done in 1 and 2 ways only. So 1, 2, that's my pair. Right? Now, next sum can be 4. Right? 4 can be done in 1, 3, only one way. 5. Sum 5. That means I can have 1, 4 and 2, 3. 1, 4 and 2, 3. Right? Obviously, I should be putting commas in between, but I will not to save my time. Then, sum 6. So, I'll have 1, 6, 2, 4. 1, 6, 2, 4. Then, sum 7. 1, 6, 2, 5, 3, 4. 1, 6, 2, 5, 3, 4. Now, do you realize it why I am writing these down? Because I know if I have 1, 5 in my subset, I cannot have 2, 4 together. Maybe I can have 2, maybe I can have 4, but together I cannot have. Right? So that is why I am writing down all the pairs which will have problem with each other. Right? So 8. 1, 7, 2, 6, 3, 5. 1, 7, 2, 6, 3, 5. And so on. You can write all the pairs. I will not waste my time on that. Obviously, you can do it yourself. So 9, 1 turns out to be 1, 8. 2, 7, 3, 6, and 4, 5. And then I will have 10. 2, 8, 3, 7, 4, 6. Then I have 11. That is 3, 8, 4, 7, 5, 6. Then I have 12. That is 4, 8, 5, 7. Right? Then I have 13, which is 5, 8, and 6, 7. Then I have 14, that is 6, 8. And then last sum that is possible, that is 15, which is 7, 8. I have exhausted all the sum of 2 numbers which are there. Right? Now, I have to find 5 element subsets. In fact, I need to find all of them. So let's start by making the cases. Right? Let's start with maybe I have 1, maybe I have 2. Right? Now I need to put in more numbers. First of all, 5 element subsets should be there. Also, let me write down the numbers also. 1, 2, 3, 4, 5, 6, 7, 8. Out of these numbers I'll take. So I'll start with 1, 2. Right? 1, 2 is there. Do you think I can put in 3? No problem. Right? Now mind it, 1, 3 is there, 1, 2 is there, which are absolutely fine. They don't have a problem with each other. Now 1, 2 done, 1, 3 done, 2, 3. Right? Now 2, 3 cannot occur with 1, 4. That means 1 is already there. I cannot put in 4. So 4 cancels. Right? Okay. Now if I cannot put in 4, let me put in 5. Let's see what happens. Now 1, 2, 1, 3 is absolutely fine. 1, 5. If 1, 5 is there, 2, 4 cannot be there. That is absolutely okay. Then 1, 5 exhausted, 2, 3. Let me check. 2, 3 will have a problem with 1, 4. It's okay. 2, 5 will have a problem with 3, 4, which will not come. 2, 5. Yeah. 1, 6. That means 6 cannot come now. Done? Okay. Now 6 cannot come, so maybe I can have 7. Let's see whether that works or not. 1, 2, 1, 3, 1, 5, 1, 7. Up. Now the thing is, if I put in 1, 7, it will clash with 3, 5. So that means I cannot put in 7 also. So let me put in 8. Let's see whether that works. Now 1, 2, 1, 3, 1, 5, 1, 8. Sorted. Nobody is having problem with each other. 2, 3, absolutely fine. 2, 5, absolutely fine. 2, 8, here. No problem is here. Cool. 3, 5, you can check. 3, 8, you can check. 5, 8, you can check. Right? So that means one such exciting subset is this one. 1, 2, 3, 5, 8. Cool? Right? Now, I started with 1, 2, 3. Right? Obviously, I exhausted 4 cannot come, then I put in 5. So let me put in 6 now. Do you think I can have 6 over here? Let's see. Cool. So 1, 2 is fine, 1, 3 is fine, 1, 6. 1, 6 is here. That means 2, 5 obviously done, 3, 4 obviously done. 3, 6. If I put in 3, 6, that means I cannot put 5, 7, 8. 5, so it's okay. I cannot put 7 and 8. That means this one will not work for me. Right? So 6 I cannot have. Obviously I cannot have 7. That is done. So that means 1, 2, 3 have been exhausted. So let's come to 1, 2, 4. Right? 1, 2, 4. 3 I'm not putting in because so let me check the next one. 1, 2 is fine. 1, 4. 1, 4 is here. 3 को डालना ही नहीं था. 2, 4. I cannot put in 5, so I have put in. I can put in 6. Let's see. 1, 2, 1, 4, 1, 6. If that is the case, 5 and 4 are already not there, so it's okay. 2, 4. 2, 4. 5 is not there. It's absolutely fine. 2, 6. I cannot put in 7 now. So that means I can put in 8. But the thing is, along with 4, 6, where is 4, 6? I cannot have 8. So that means I cannot put 7, I cannot put 8. That means this is also done. Right? So 1, 2, 4 is exhausted. You will realize 1, 2, 5 will not work. In fact, 1, 2 thing will not work. Right? You'll move on to the next one. You will exhaust 1, 3. Right? You need to exhaust it because this is a 10 marker. You need to put in some effort. Right? The only other set that you will find that is exciting, that is 1, 4, 6, 7, 8. Right? So he asked, write the number. So there were just 2. 0, 2 is the answer. Now, second part was related to this one. He says, in above question, write the sum of all elements of each possible 5-element subset. So you need to add these and write the answer, and that will turn out to be 45. Alright, on to the next one. Now, this is obviously the third part of 23rd question. He says, define remainder A, B to be the remainder when A is divided by B. Right? So, for example, we have remainder 10, 7. So, when 10 is divided by 7, the remainder is 3. That is why we have written it 3. Remainder, when 20 is divided by 5, obviously remainder is 0. When 3 is divided by 4, the remainder is 3. Now, he says take n greater than or equal to 10. So, either I can take 10 or I can take 11 or I can take 12 and so on. Right? Now, he says for each positive integer k, where 1 less than equal to k less than equal to n, we have defined the term like this. Right? Now, he says write the number of all integers. So, n varies from 10 to 89. 10 is included? Yes. For which the set this of n integers is exciting. Right? The thing is, the question doesn't start. Right condition is there. I do not understand how to start the question. So what I can do is, now he says, define this when n varies from 10 to 89. Let me take some value of n in order to understand, right? So maybe you can start with 10, I'll start with 11. No rule about it. So I will take n to be 11, right? So that means my k varies from 1 to 11. That makes sense, because we will be talking about the terms x1, x2, x3, x4, so on till x11, right? Now, how do I write x1? He says 2 into n. N was 11, so I'll say 22 into. Now, 22 is multiplied by this. Remainder, when? Now, k we have taken to be 1. 1 square is divided by 11 in this case, so that is 1. Plus k, which is 1. First term, right? No need to simplify it, don't worry. Second term. Now, obviously 2n remains same, so 22 will be there, into. Now, 2 square, remainder when 2 square as in 4 is divided by 11, that would be 4 plus 2. Next, 22 as it is, into. 3 square divided by 11, that is obviously 9 plus 3. Right? So, let me write the terms, let's see what happens. Right? So, x4 is nothing but 22 into 5 plus 4, fine. Till now, I cannot see anything. Right, x5 is 22 into 3 plus 5, then 22 into 3 plus 6, okay. X7, that is 22 into 5 plus 7, then 22 into 9 plus 8, then 22 into 4 plus 9, then 22 into 1 plus 10, last obviously 22 into 0 plus 11, right. Now, if you look, can you see what is the observation over here? I think observation is pretty clear. 14953, then 359410. This thing, this thing. Okay, note it down. And also 3 is twice. This you must have analyzed. If you don't understand the question, at least we'll take some values and see what is happening. Right? Next, we can take n as 12. Let me write that one also. So that means I'll write x1 first. So x1. Now 2 into 12, that would be 24. Into. Remainder when 1 square is divided by 12. So I understand that is 1 plus 1. Cool. Next would be 24 into 4 plus 2. Next would be 24 into 9 plus 3. Right. Next would be 24 into 4 plus 4. Then 24 into 1 plus 5. Then 24 into 0 plus 6. Can you see the pattern again? Right, x7. Now it will be 24 into 1 plus 7. Then 24 into 4 plus 8. Then 24 into 9 plus 9. 24 into 4 plus 10. Then 24 into 1 plus 11. Then last 24 into 0 plus 12. Since we have a lot of time for the 10 markers, we need to put in a little bit effort. Pattern will only be observed if you write the term. Right? Now you can see the pattern again. 1, 4, 9. 4, 1. Then obviously 0 will come. 1, 4, 9. 4, 1, 0. Done? Now let's look at this. Now first of all, I need to find those subsets which are exciting. That means sum of 2 should not be equal to the sum of other 2. Right? First of all, I'll check for this one. I'll check for each and every case. Obviously, I will not say, oh, sum of this, sum of this, sum of this. I'll check like this. Sum of this, sum of this, sum of this. Right? It hardly takes time. Why? Because here 22 will be common. So, in adding terms, it is a little bit easier. Right? Now, look for 4 integers over here such that the sum of first 2 is equal to sum of other 2. In this case, you can, if you take these 2, I am just taking randomly 2, there might be others, obviously there will be others. Right, 4 and 8. 4 and 4, this is the 10 one. Right, you can see 24 into 4, 24 into 4 plus 2 plus 10, same thing, 24 into 4, 24 into 4 plus 4 plus 6. Right, the sum is same. Now here the sum is same. Right? Here the sum is not same. Now you need to analyze a little bit more, you will check for n is equal to 13. Right? Again, when you check for n is equal to 13, you will realize you cannot find any. Right? Why? Because repetition, see, 3 occurs twice. That happens in 13 also. Repetition is there. Then you will check for n is equal to 14. You realize that repetition is not there, right? And that is why somehow you are able to find the numbers, 4 numbers, that sum of 2 is equal to sum of other 2. That happens in 14. 15 also, you will not be able to find this kind of repetition. That is why you are able to find it. 16, the same way. Now, when you come to n is equal to 17, again repetition is there. 3 comes here, right? In n is equal to 17, 13 repeats, right? And you are not able to find out the number, the exciting integers in this case. So, what are you observing here? Whenever prime numbers, it happened with 11, it happened with 13, it happened with 17, right? Whenever the prime numbers occurred, there were no exciting subsets because repetition occurred here. 3, 13, repetition again was there, 17, repetition again was there, right? So that means whenever prime numbers occur, we can find the exciting subset, right? Now he says from n varying from 10 to 89, how many exciting subsets would be there? Now we know n is equal to 11 will have 13, 17, and then next one would be 19, then 23. You just need to count how many prime numbers are there till 89, right? And that you obviously can. That is why the answer will turn out to be 20. Alright, on to the next one. Now he says a positive integer n with n greater than or equal to is called a Nella number if there exists a positive integer x where x is less than n and there exists a positive n such that two conditions, right? Two conditions are m is not divisible by x and by x plus 1. M is not divisible by x and m is not divisible by x plus 1. Okay. Second condition, m is divisible by every other positive integer from 1 to n, both inclusive. It should be divisible by every other. That means except for x and x plus 1, it should be divisible by every other positive integer. Right? Now when I read this statement, I am unable to understand it better. What I can do is, he says that n is equal to 7 is a Nella number. Let me just analyze it. How this n is equal to 7 is a Nella number? Let me check. Right? N is a positive number greater than or equal to 3. So n is equal to 7. I can say this is a Nella number if there exists. That means I need to show an existence of a positive integer x. I need to show that there is a number x. Now, x should be less than n. That means x should be less than 7. Now, x less than 7. That means possible values of x. 1, 2, 3, 4, 5, 6. Done? Right? I need to show the existence of this. And there should exist a positive integer m. Such that, up two conditions are there. M is not divisible by x and x plus 1. X and x plus 1. Right? Okay. And the second condition, m is divisible by every other. Right? This is the condition that I need to check. Now, hardly x has any possibilities. Let me check. X equal to 1. Let me see whether x equal to 1 satisfies the thing or not. Now he says m should not be divisible by x as in not be divisible by 1 and x plus 1 not divisible by 2. Okay? Should not be divisible by 1, not divisible by 2. But m should be divisible by every other. That means except for 1 and 2, every other. 3, 4, 5, 6, up from 1 to n. So 1 is obviously rejected here. N, that means 7. Now you need to find m which is not divisible by 1 and not divisible by 2, but should be divisible by 3, 4, 5, 6, 7. Any number which is divisible by 3 would be divisible by 1, right? So that means you are unable to find m. That means x equal to 1 is not my existence number. Right? Let's move on. X equal to 2. Fine. Right? That means I need to find m which is not divisible by 2 and not divisible by 3. Cool. But it should be divisible by every other. That means m should be divisible by 1, leave 2, leave 3, 4, 5, 6, 7. Now wait a second. M should be divisible by 4, right? Any number which is divisible by 4 will be divisible by 2. Contradiction. That means there is no m. That means x cannot be 2. Rejected? Third, let's see what happens when x equal to 3. Right? Now m should be such that it should not be divisible by 3, it should not be divisible by 4. But it should be divisible by every other positive integer. That means m should be divisible by 1, 2, 3, 4 more, 5, 6, 7. Now mind it, m is divisible by 6. Any number which is divisible by 6 is obviously divisible by 3. That means you are unable to find m. That means x cannot be 3. Now, x equal to 4. M should be such that it should not be divisible by 4 and it should not be divisible by 5. But m should be divisible by 1, 2, 3, 4, 5, no, 6, 7. Now, the thing is, if I look 2 divisible by 2, it might be divisible by 4, might not be. I cannot conclusively say. 3 might be, might not be conclusively. I can't say anything. 6 might be divisible by 4, might not be. Conclusively, I cannot say. 7 conclusively, I cannot say. That means I'm not able to say precisely anything in this regard. So maybe I'll be able to find it. Right? Now, mind it, m should be divisible by 1, 2, 3, 6, 7. That means it should be a multiple of 2, it should be a multiple of 3, it should be a multiple of 6, it should be a multiple of 7. Now, there are too many numbers. Right? Common multiples I need to take. Common multiples. Let me find out the least common multiples, right? If I can find out the least common multiples, any multiple of that would be here. So let me check for the LCM. Now, LCM in this case will turn out to be 42. Right? Let me check. 42 is definitely not divisible by 4, not divisible by 5. Done. 42 is divisible by 1, 2, 3, 6, 7. That means I am able to find m. That means I am able to find x. If there is an x for which the two conditions are satisfied, that means this n is a Nella number. Right? That means what he has said, for example, n is equal to 7 is a Nella number. For that, we have been able to find such a x equal to 4, for which there is an m which satisfies the two conditions. Right? This is what we have understood using the example. But that is not a question. Our question is there. Let me just erase it and then I'll move on to the question. Right. My question is, how many Nella numbers are there which from 50 to 61? Or I can just write it like this. 50, 51, 52, so on, till 61. Both include. So I need to see how many Nella numbers are there amongst these numbers. Right? Question paper is there in the description box. I'm not writing it because I need this. I need to check whether this is a Nella number, whether this is the one, this is the one, this is the one, and so on. So let me start with the least one. Let me take n as 50. I need to check whether n is equal to 50 is a Nella number or not. For that, I need to have an existence of x. Right? I need to have an existence of x. Now, x should be what? Less than n. That means possible values of x, 1, 2, 3, so on till 40. Cool. Now, along with this, I should be able to find positive m such that m is not divisible by x plus 1, and m should be divisible by every other positive integer from 1 to n. Right? Now the thing is, I have too many options for x. Let me start with first one, x equal to 1. Mind it, x equal to 1. It's a very obvious thing. Let me see whether I can find m or not. Now I want m which is not divisible by 2, which is not divisible by 1 and not divisible by 2. But it should be divisible by 3, 4, 5, 6, so on till 50. Right? Now any number which is divisible by 3 would be divisible by 1, right? So obviously x equal to 1 to nahi ho sakta. What about x equal to 2? Again the same thing. Why? Because I need a m which is not divisible by 2 and not divisible by 3. Right? So I need m which is divisible by 1, 4, 5, 6, so on till 15. Now any number which is divisible by 4 must be divisible by 2. Right? That means if I want to look for such number, I will look for the tiny number. Why? Because prime factors, if I take 3, obviously I will have 6. Right? Every other 6 would be there and 3 is there. Then if I take 11, even if I take 11, every other it should be divisible by 22. Again factor of 11 is there. That means if I want to look for x, I will look towards the bigger side, right? To the other end. To the other end. How should I start? To the other end. Now, obviously, I would want to look for a prime number, right? To the other end. Let me see. 50, less than 50, which prime number can I take? 47. Let's see what happens. So let me take x equal to 47. Let me check. Right? I need to find m which is not divisible by 47 and not divisible by 40. But it should be divisible by every other. So it should be divisible by 1, 2, 3, so until 46, 49 and 50. Right? This is absolutely fine. 47 is a prime number. I get it. 48. Now 48 is nothing but 2 raised to 4 into 3, right? 16 into 3. Now obviously m would be divisible by 16 and m would be divisible by 3. That means m would be divisible by 48. So that means contradiction is there. I cannot have x equal to 47. Let me go further down. So x equal to 47. Instead of that, I can go x equal to 47. Right? That means I want m such that it is not divisible by 43 and not divisible by 40. Right? Okay. And m should be divisible by every other. So 1, 2, 3, I will have 42, I will have 45 and so on till 50. Right? Mind it, any number, because 44 is there, that means 4 into 11, m is divisible by 4 and m is divisible by 11. Both are there, right? So if it is divisible by 4, it is divisible by 11. It has to be divisible by 44. Contradiction is there. That means x cannot be 44. Rejected? Okay. X equal to 41. Now, not divisible by 41, not divisible by 42. Mind it, 42 is 7 and 6, right? Obviously, the number would be divisible by 7 because every other he says, and it will be divisible by 6. Rejected? Right? You can check for x equal to 37 yourself. I will go to x equal to 31. Let's see what happens. Right? Now, x equal to 31. M. It should not be divisible by 31 and it should not be divisible by 32. Right? M should be divisible by every other. 1, 2, 3, so until 30. Then I will go 33. Then I will go 50. Right? Okay. Now there is a problem. Now I am unable to think. So what I'll do is M is divisible by all of these. So let me write the LCM. Now LCM I can write in terms of prime factors. Right? So 2 part would be there, 3 part would be there, 5 part would be there, and so on. Let me write the LCM. Now, highest, when we write LCM, we write the highest power of 2. Now, mind it, 16 would occur, then 32 is not there, then there. Right, so 16 have the maximum power of 2. That means in LCM, I will have the maximum power as 2. Right, so in my LCM, I have 2 raised power 4. Right, 2. And then I have 3 raised power, the highest power would be 3, because 27. Right, and so on. Now, the thing is, m is divisible by this number, right? Or maybe I can just take m to give you the LCM, right? Any number which is divisible by 2 raised to 4, as in 16, might not be divisible by 32, right? Okay, that means I found this. And 31 to I means, so I must. That means, if I take my m to be the LCM of these numbers, right? I will get such an x. Now, if I am able to find the existence of x, that means my number n is equal to 50 is a Nella number. Right? So that means this is a Nella number. Let me check for n is equal to 51. So check that. Okay, 51. 51. Let me write this thing. Mind it, let me check there itself. Let's see what happens. Right? M should be divisible 1, 2, 3. Let me go on to 50. Right? Absolutely fine. Because 51 is nothing but 17 into 3. Again 17 I over 3 is already I over. Again my LCM will look something like this. Right? Again this number is not divisible by 31. This number is not divisible by 32. Again I have an existence of a number x. So that we have n is equal to 51 as a number. Right? Let me check for 52. On the same lines I can do. If I do 52 also, no problem. That means 52 is also there. Right? And so until, let me talk about 61. Right? Now, 61. So again in my LCM, right, maybe I will get my 61. This number is definitely not divisible by 31. And this number is definitely not divisible by 31. So there is an existence of an x, which is x equal to 31, which will make n is equal to 61 as my Nera number. That means all of these numbers are Nera numbers. He asked me how many Nera numbers are there from 50 to 61, both inclusive. All of these. How many numbers are these? These are 12 n numbers. So that means the answer for the first part is 12. Right? Now, I will continue with the analysis that I have done for the second part. Now, the thing is, for the second part, the question is, you need to find the number of Nena numbers from 50 to 2017, both inclusive. Right? Now, let's see what happens. Now, I was continuing with this number itself. Let me put 62 also. Let me put 62. Let me check because I've already checked to 50 to 61 as well. Let me go for 62. Let's see what happens. Now 62, I will put my 62. Mind it, now in the LCM I will have 62. Right? Okay, in my LCM I have 62. If I write the prime factorization, that is 2 into 31. That means this number now becomes divisible by 31. So x equal to 31 cannot be the existent x for this one. Right? Okay, fine, cool. So 31 नहीं मिला मुझे, जो मुझे मिल रहा था बार-बार. Right? So the question is, I have been stuck because वो मुझे मिल नहीं रहा. So let me check for n is equal to 62. Right? X equal to 31 does not work for me. I will not go for the prime numbers less than this because I can clearly see that will not be the case. So I will go on the higher side. Higher side, higher side, higher side. अब 41, 50 to 61 के लिए नहीं मिल रहा था. Obviously 62 के लिए तो नहीं मिलेगा. Right? 43, no. Then 47, no. Because it was not even there for 50 to 61. How can it be there for 50 to 62? So let me move back up. Right? X equal to 47. Prime number greater than 47. That is 53. So let me take my x to be 53. X less than 62 I want, and I will take my x to be 53. Right? I will erase this now. Alright, I'm erasing the answer for the previous one also because now I need more space. Cool. Now, x equal to 53. That means I want m which will not be divisible by 53 and not by 54 because x plus 1. Right? Okay. Now, what else? Also, I want m to be divisible by 1, 2, 3. So until I will get 52, I will get 55, I will get 52. Right? Now mind it, when I write the LCM, this is nothing but 2 into 27, 2 is present over here and 27 is present over there. That means this m will not work. Right? This m will not work, that means this x will not work. This x is not working. So 53, if I go beyond 53, 55 no, 57 no, 59. I can check for 59. Now if I want to check for 59, so this is not divisible by 59, not divisible by 59. Again, when I'm writing the LCM, right, I can rectify this. I will go to 58 and then I'll go to 61 and then 62. 62. Right? Now, 60 is nothing but 15 into 4, so 3 into 5 into 2 square. Obviously, 3 is there, 5 is there, 2 square is there. That means the LCM would be divisible by this. So 59 doesn't work. Right? Next prime number that I can use, that is 61. Now 61, this is 60. Again, this is 2 into 31. Already it's there. Cool. That means I am unable to find x. That means n is equal to 62 is not my Nena number. First number I have, this is not my Nena number. Right? Let me check for 63 now. Let's see what happens. So, 63. Right. Right. I have checked for x equal to 61. Obviously, since it didn't even work for 62, how can it work for 63? Okay, rejected. 63 was also done. 64, you will realize it is not done again. Then I have my 65. Let's see whether that works or not. Now, let me put it here. 65 and x less than 65. Right, 63 is not my prime number. Right, you'll realize if it is not even working for 62, 63, 64, it is not going to work for 67, then 66, and so on. The thing is, I'm unable to get the thing. But why is that happening? And if I want to find Nena numbers, where should I go in order to find it? Where should I go? Now, the thing is, when we were analyzing, the first thing that we got, x turned out to be 31. Right? We took m not divisible by 31 and not divisible by 31. Now 31 was a prime number, perfect. And 32 is actually a nice number, isn't it? It is 2 raised to 5. Not a coincidence, not a coincidence, 2 raised to 5. That helps me out. Now, let me see. 62, 63, 64, 65, 66. Let me move forward, but till there. Right, 64 2 raised पर 6 होगा, right? इसके आसपास ही थी मैं. अब मैं जाती हूँ next बार के पास. So let me take 127. Let me see what happens. Right, so I will take my n as 127. Right, that means I need to find an existence of x which is less than 127. That means x can be 1, 2, so on till 126. And I need to find m which is not divisible by x and by x plus 1 but is divisible by every other. So let me look for my x. Obviously x I'll take it to be a prime number. Let's see what happens. So first prime number that I can think of, that is 119. Which is not 113 is the one. 113 is the prime number. Yeah, 130. Right? Now, if I go to this one, I need to find m which is not divisible by 113 and not divisible by 114. But it should be divisible by every other. So 1, 2, 3, so on till 112, 115, 120, 127 actually. Right? Okay. Now the thing is, here number 114, you can write it as 2 into 57. 57 will crop up and 2 will be there, so it's fine. So that means x equal to 113 will not work. Right? X equal to 113 is not working. That means I will not go further in. I've checked the largest prime, it is not even working. So lesser one, it will not work. So that means n is equal to 127 is not a Nena number. Similarly, you can check for 128. Right? Let me check. In fact, you can do that for yourself, right? It will also not turn out to be a Nena number. Let me go for 129. Let's see what happens. 129. So I want x less than 129. So that means I'll go till 128. Right? Now, I will go for the prime numbers. Prime numbers less than 129. So that is 127. Let me see whether I get a Nena number or not. Right? So I want m which is not divisible by 127. And not divisible by 128. Now 128 I like it. It's a power of 2. 2 raised to 7. Right? And it should be divisible by every other. 1, 2, 3, so until I have 126, I have 129, and then I have 129 to be sure. Cool. Right? Now the thing is, if I write the LCM of this one, The highest power of 2, that is 64. So that is 2 raised power 6. Right, that would be there. And obviously 3 raised power, it would be 81, right? Yeah, 81. 3 raised power 4 into something. This number is definitely not divisible by 127. And this number is not divisible by 128. Why? 2 raised power 7, 2 raised power 6. Right? Okay. That means I got x equal to 127. Which is making my 129 a nano. Right? Let me check for 130. Same thing will work for 130 also. 121, 132. That means in this chunk again I am getting my number. Now, obviously I am getting all of these numbers. Now, where should I check next? Mind it, near the power of 2, 64, 128. So I can check for 254. Check it out. Right? It will turn out to be not a nano number. 255, not a nano number. 256, not a nano number. Right? That means in these chunks you will check. And then you will check around 512. Then you will check around 1024. Next part we have it 217, that is 2048. That's it. Right? So if you want to look for numbers, look in these chunks. Around 64, like 50 to 63 you can check. Then 65 to 128 you can check. 129 to 254 you can check. So check in these chunks. Right? Now, answer turn out to be from 50 to 60 because ये तो पहले आ गया था हमारे पास 12. Right? And in the next one, you will find 124, and then in the next one you get 259, or you interchange it, whatever you want to call it, right? So these are all the nano numbers. So in total, I have 393 nano numbers, right? In the question, he does say write the sum of digits of k. So obviously, the answer in this case for the second part, that is 50. Right? Now, mind it, 10 marker is an investigative question, right? You need to find an answer. You don't need to prove whether there is an existence or not. So, through hidden trials, you are able to find the numbers, because step by step, I have exhausted all the numbers from 50 to 2017. Obviously, I did not take one by one. I did not do that. But I did exhaust from 50 to 2017. So, hidden trial is a great method in 10 marker. If you are unable to devise a method, just exhaust all the cases. It does not take that much time. Right? After all, it is a 10 marker question anyway. Right? So, with this, I will end the discussion. All the best for your IOQM. I hope you do really well. I will see you next time. Thank you.